Guys, today we're gonna practice with our trig ratios, so on our unit circle. First, I'm always going to start by drawing my 45, 45, 90, my 60, 30, 90, and my 30, 60, 90. Yes, I know they're the same triangle. These two are the same triangle, but I'm still gonna draw both. Okay, so 45, 45, 90s. If I have a radius of 1, I have a vertical length of root 2 over 2, and the x length would be root 2 over 2. 60, 30, 60, 30, 90, across from 60 would be root 3 over 2, my hypotenuse of 1, and then across from 30 is always half the hypotenuse, so 1/2. Make it a little smaller. All right, and then across from 30 is 1/2, the hypotenuse is 1, and the long side is root 3 over 2. Long leg, excuse me. Okay, so I'm going to use those for the rest of these problems. So what we're going to do is sketch the angle and then write the 6 trig functions, the 6 trig ratios, okay, at the given angle. So 210 is in the third quadrant. And so I'm going to start on the positive x-axis and then open up. It's basically 30 degrees past 180. So it's going to be right here. And like I said, it's 30 degrees away. So theta is equal to 210. But what I'm actually concerned about is its reference triangle. So the triangle that is connected to the x-axis, the acute triangle connected to the x-axis. So this triangle right here is a 30-degree triangle. So because it's a 30-degree triangle, I can label in the side lengths just as if it was in the first quadrant, except I have to be careful of the positive, negative signs. So in the third quadrant here, all ordered pairs are, I'm going to move to the left and down. So the x's are negative and the y's are negative. So I'm going to look at my triangle from up here, my 30 degrees. Across from 30 is 1/2. Across from 60 is root 3 over 2. And the radius we're going to say is 1. We can scale up or down the triangle by any factor, just like you did in geometry or math 2, okay? The problem here is that we're in the third quadrant, so this is going to be negative root 3 over 2 and negative 1/2. Cool? Cool. All right, so the sign of theta would be, I'm always standing in the middle of at the origin, okay? So I'm going to look across at my acute triangle to a negative 1/2 over the hypotenuse, which is 1. So this is just negative 1/2 over 1, which is negative 1/2. Cosine would be the adjacent or the x over 1. So that would be negative root 3 over 2 over 1, which is negative root 3 over 2. Tangent is opposite or y over x. It's the y over the x, which is negative 1/2 over negative root 3 over 2. To simplify, we need to multiply by the reciprocal, negative root 3 over 2. That is not the reciprocal. Negative 2 over root 3. The 2's cancel, the 3's cancel. Anything I do to the bottom, I must do to the top as well. So negative 2 over root 3. I can see that the 2's cancel. The negative 1 times negative 1 becomes a positive 1, and on the bottom is root 3. Do we leave it like this? Nope. We rationalize, so we're going to go ahead and multiply by root 3 so that we get a whole number on the bottom. Okay, so I get root 3 over 3, positive root 3 over 3 for my tangent. All right, we're going to do secant, cosecant, and cotangent. So cotangent is the reciprocal. These are all reciprocals. So cotangent would be I can just take what I got for tangent, 3 over root 3, and then reciprocate it. And then I'm also going to rationalize. So root 3 times root 3. That becomes a 3 root 3 on the top and a 3 on the bottom. They cancel to give me root 3. Secant, let's see, I started with 2, negative 2 over square root of 3 from cosine. And I'm going to rationalize the denominator. Equals negative 2 root 3 over 3. Okay. And then lastly, our sine ratio was negative 1/2. So now this is going to become negative 2 over 1. So negative 2. Okay. 7 pi over 6 is the same angle. So we're going to change that. I'm going to make this 13 pi over 6. And this time, I noticed that 13 pi over 6 is greater than 1 full rotation, so I can break this up into basically 2 pi, actually let's do it like this, 12 pi over 6, which is just 2 pi, plus 1 pi over 6. So this is 1 rotation plus a little bit. I'm going to go ahead and I can just graph the pi over 6 and it will act the same as 13 pi over 6. So I'm going to start here and graph in pi over 6. And pi over 6 is 30 degrees. So I get, this is, I drew the triangle so small. 1/2, 1, and root 3 over 2. Any point from the first quadrant is positive x and a positive y. All right, so sine is just the y length. It's y over 1, so it's 1/2. Cosine is x over 1, so root 3 over 2. And all of these are positive because the lengths are positive, positive. Tangent would be y over x, which is 1/2 over the root 3 over 2. And then we multiply by the reciprocal, just like we did above. You're going to see a lot of the same calculations because it kind of, the pattern repeats itself every time in every quadrant. Okay, so we get 1 over square root of 3. Then what do? We rationalize. So I get root 3 over root 3 times root 3 is 3. Positive. Okay, cosecant. We take the reciprocal of sine, so that would be 2. Reciprocal of cosine, so 2 over root 3. We rationalize. Equals 2 root 3 over 3. Reciprocal of cotangent would be 3 over root 3. Again, rationalize. Giving us 3 root 3 over 3 cancels to give me root 3. All right, next one. 7 pi over 4. So 7 pi over 4, I'm doubling the denominator and so I'm doubling 4, which gives me 8, and subtracting 1, which gives me 7. So this is in the fourth quadrant. So I'm gonna draw my 45 right here. So 1, 2, 3, 4, 5, 6, 7 45s make 7 pi over 4. Okay. So I'm going to go ahead and say the outside angle here is theta is equal to 7 pi over 4. The inside angle is pi over 4, and that is our reference angle. So I'm going to be referencing the triangle 45, 45, 90. Okay, so going back, if I have a radius of 1, I have side lengths of root 2 over 2 and root 2 over 2. And because this is the fourth quadrant, I just have to be careful about the signs S-I-G-N-S. Okay, so in the fourth quadrant, The x's we move positive, and the y's we move negative. So the y here is going to be negative, and the x is going to be positive. All right, so sine is y over 1. So that would be negative root 2 over 2 over 1, which is just negative root 2 over 2. Okay. The x over 1 is cosine, which is root 2 over 2. Tangent is y over x. So the y value of the triangle over the x value of the triangle, which gives us negative root 2 over 2 over positive root 2 over 2. What's anything divided by itself? It's 1. So this is going to be negative 1. Okay. Then we use those to help us do our secant, cosecant, and cotangent. Let's start with cotangent. The reciprocal of negative 1 would be negative 1. The reciprocal of root 2 over 2 would be 2 over the square root of 2. And of course, we rationalize the denominator. So 2 root 2 over 2. The 2's cancel, giving me just root 2. Okay. The same thing is true for the cosecant, which is the reciprocal of sine. So negative 2 over root 2 multiplied by root 2, which gives me negative 2 root 2 over 2, cancels. So I get negative square root 2. All right. 2 pi over 3 is in the which quadrant? It is in the second quadrant because the numerator is one value less than the denominator. So I'm missing one wedge. Theta is equal to 2 pi over 3. And I'm missing one wedge of pi over 3, which is I'm just going to make this line longer, which is just a 60-degree triangle. So I'm going to draw my reference angle, the angle that connects to the x-axis. This ordered pair right here is going to act just like the triangle pi over 3 from the first quadrant, just reflected. So in the second quadrant, this ordered pair, we would count the x and y as negative and then positive. So across from 60 is root 3 over 2. Across from the angle 30 is 1/2. And the radius, we're calling it 1. So what do I need to make negative? I need to make the x value negative. All right. Sine is the y length over the hypotenuse. So y over 1, which is root 3 over 2. Cosine is the x length over the hypotenuse, so x over 1, which is negative 1/2. Tangent is the y length over the x length. It's the slope of the triangle, really. Okay, so root 3 over 2 over negative 1/2. I'm going to say these are the answers. Multiply by the reciprocal, 2 over 1. The reciprocal of the denominator, because I want to make this denominator 1. Okay, so this is negative root 3. Okay, secant, cosecant, and cotangent. So cotangent, I can write this over 1 if I want. So that would be negative 1 over the square root of 3. Rationalize. So negative square root 3 over 3. See, these patterns repeat. Okay. Secant would be negative 2 over 1, which is just negative 2. And cosecant would be 2 over the square root of 3. We rationalize to make a whole number or a non-terminating decimal. A terminating decimal. 2 over 3 over 3. 2 root 3 over 3. Yes, that's it. All right, so that's how you do those. And then we're going to evaluate now the following equations using what we know about trig, basically. Okay, So I want to evaluate f of 11 pi over 6. So I'm going to be like f of 11 pi over 6. That's my theta. I should change this to theta. Okay. Is negative 4 times the sine of 11 pi over 6. So I need to figure out what 11 pi over sine of 11 pi over 6 is. So I'm going to draw in my angle. 11 pi over 6 is in the fourth quadrant. 11 pi over 6. And the reference triangle would be pi over 6 right here. So this is a length of negative 1/2 root 3 over 2 and 1. And sine would be the y value over 1. So f of 11 pi, I'll just write the sine of 11 pi over 6 is the y over 1, which is negative 1/2. So I'm going to 11 pi over 6 is equal to negative 4 times the ratio of negative 1/2. So f of 11 pi over 6 is equal to 2. That's it. Okay. Next. So we're going to do g of theta. So g of negative 2 pi over 3 is equal to negative 4 times the secant of negative 2 pi over 3. Okay, so I need to figure out what the secant of negative 2 pi over 3 is. So I'm going to go ahead and draw in my angle. This time I'm opening to the clockwise direction, and it is in the third quadrant because I'm spinning 2 of the 3 pieces or wedges. I have a reference triangle here. I connect back to the x-axis. So my reference triangle is pi over 3. I'm missing 1 pi over 3. So I have across from pi over 3 or across from 60 is root 3 over 2. Negative because it's in the third quadrant. Negative 1/2 and 1. Secant is the reciprocal. So secant of negative 2 pi over 3. I'm actually going to figure out what the cosine of negative 2 pi over 3 is, which is the x over 1. So the secant is going to be 1 over x. So I'm going to go ahead and take my radius, which is 1, and divide by the x value. Divide by negative 1/2. And then multiply by 2 over 1. So I get those cancel, leaving me with negative 2. So the negative comes from the bottom. Okay, so g of negative 2 pi over 3 is equal to negative 4 times negative 2, which is positive 8. And that's it.